Okay. Hello and welcome to Zarhus Developers Meetup. This is third Zarhus Developers Meetup. This event, so in case you are lost and you just get here by accident, this event is dedicated to Zarhus operating system, or you can say framework for making operating systems. And here we would like to give you some heads up about our accomplishment over last 3 months and follow up with our mission and vision and how we essentially realize what we initially discussed in the first Zarhus Developers Meetup. You can get back on YouTube and check those videos. Just in case you are really lost, then Zarhus is an embedded Linux distribution based on Yocto. But we're not doing only Yocto. We're doing also other stuff, and I would like to dive a little bit deeper into that in later slides. It's a distribution developed by 3MDEP, and the main point of this distribution is to simplify provisioning, integration, and maintenance of embedded platforms with very strong focus on the security, verifiability, auditability, transparency, trustworthiness, and of course, there is no strong security without very good immutable root of trust, ideally hardware root of trust. And of course, if we have root of trust, then we have to have some chain of trust to deliver some transitive trust to our target application, whatever it is. Yeah. A little bit about this forum and about the rules. So this is for the Zarhus team, so 3MDEP Zarhus team and our partners to share the knowledge. It is related to our development, either to commercial one or the stuff that we want to do because we just love it and we like to mess with various things. And this is where this event is where we report it. Event happen quarterly, but we will change that a little bit. I will talk about that later. A short presentation, 20 minutes, focused on demo, of course, except this one. This one is more about status, community status, vision, mission, and kind of communicating bigger picture. There's little time for questions, just 5 minutes. Typically, we don't have big audience, so there is not much for questions. YouTube already got the playlist for ZDM1 and ZDM2, and you can also watch those on the cfp3m.com, as well as on dedicated Zarhus Developers Meetup websites. I just checked yesterday number of views, and I don't know if we're surprised or not. Securing Embedded Linux by Michał was the most popular one, over 100 views. Not a lot, but still something. So congratulations to Michał. The second was CrossCon, and third one was OpenBMC. That was the statistic I checked yesterday. And what's the agenda today? So we have this welcome presentation when I will talk a little bit about vision and community status. Then context-based authentication by Mateusz, based on CrossCon experience from CrossCon project, status of Dasharo toolsuit and roadmap of it by Daniel. Then Maciej will talk about hardware bucket security in Android, and then a little bit more about compliance, NIS2, and how it relates to the Zarhus and embedded systems software development by not Maciej, but Kamil. I'm sorry for that. Okay, and then we will have at 8 p.m. we will have closing notes. I would like to let you know about some events we plan to attend in upcoming months. Okay, what will be in my presentation? I would like to touch a little bit about Dasharo and Zarhus ecosystem, how high-level things look like, and then how things work in more detail regarding release process. Then I would like to recap the Cube's Air motivation and Zarhus role. I hope Zarhus will play this role and how I envision the Zarhus role. Then a little bit about business model. There are slight small differences in the business model in comparison to last presentation. And I have two kind of more extensive slides about Zarhus ecosystem alignment, which is kind of formalizing our existing processes, tooling, to provide better explanation to customers. And then Zarhus hardware certification, which is also something that we've just formalized existing pieces, which are scattered and working depending on the customer, maybe not in whole pipeline, but in case any customer would like to have like whole coverage, then I would like to explain how this could look like. Okay, regarding the Sharo and Zarhus ecosystem, situation is like kind of quite simple. So we have some silicon vendors which typically commit some code. Of course, sometimes those silicon vendors behave alone. Sometimes there is like some broker for that, like Linaro or some companies which are operating in embedded Linux environment or embedded systems environment, and they hiring those organization or those companies. They commit stuff to upstream so the whole ecosystem can benefit. And this is for all silicon vendors, or x86, Power, RISC-V, ARM especially. And of course Zarhus team and Zarhus as a framework, as a concept, which covers various activities in 3MDEP, picks up from this upstream to deliver some value to either to community, either to various OEMs, ODMs, or even value others resellers or enterprises, like which we kind of have umbrella name for bigger organizations. The same happened with the Sharo. And of course, we hope that when we deliver that code, those organizations, after some time, they will improve something. Maybe they will hire someone else. Maybe they will hire us again. And they will push to upstream. And we're hoping that this ecosystem will grow and will be stronger, more resilient, and so on. In the past, I showed some version of this picture to show a little bit of role of Zarhus in this. You can note that there are some additional icons in this box. Also here, there is Orbit, there is heads here. Initially, I guess there was no slim bolt holder. Also, it was added at some point. But essentially, this diagram showing kind of three silos in which booting the platform works. But maybe let's start from the top to understand what is going on here. We typically would like to educate ourselves if we don't have enough deep inside knowledge about what's going on. So that means that we need training. And the training could be about silicon vendor security technology, which we're trying to specialize in because we believe that strong root of trust is a foundation for any trustworthiness in computing. And of course, our mission is to improve the trustworthiness of all possible devices that exist. Of course, we have limited impact, but still trying. Of course, Dasharo is one ecosystem. I will not dive here because, but we can say what's the difference between Dasharo and Zarhus. So typically, Dasharo is more like embedded firmware, BIOS related stuff. And you can say that Zarhus is anything like operating system, bootstrapping the operating system, anything that is closer to operating system than to some bare BIOS firmware, then it's probably more like a Zarhus, yeah? Of course, there are some areas which are not clear, which we can discuss and argue, but that's not the point here. The point here is that we're adding some stuff, we're thinking about what kind of languages we will use, like we love C, we also use Python a lot, we use Bash a lot, but we also would like to, we leverage already Rust in some projects, we leverage Go in some projects, but of course we would like to do more of that. There are some projects which are closely associated with that. So for example, uroot is a Go rootfs, rootfs which leverage Go utilities, like Golang utilities. Yocto, of course, is one of our frameworks. OpenBMC is in Yocto. U-boot, of course, there is trusted firmware here, of course, Linux kernel. And if Linux kernel, and we're talking about the low-level stuff, there is something like Linux boot. Of course, Linux boot is very close to heads, so probably heads also could be here, but for historical reasons, is not here. Maybe in future. And this ecosystem is growing and expanding, and there's even more needs here. So what are the new icons here? Maybe I will start from right side because maybe not everyone knows this icon. This is Buildroot. So we also touching Buildroot. In CrossCon, we use Buildroot for generating images of the VMs. OpenWRT is also a thing. We probably will have our own Zarhus WRT looking at the needs of our customers. Those icons are no, but there are some new here. There is StageX. So StageX is verifiable compute, verifiable. It's technology which supports verifiable computing, and essentially from very small, like 256 bytes or something like that, can bootstrap a whole ecosystem, all like recompile in a redistributable way all the components that exist. And thanks to that, of course, we have tracking and very strong supply chain security for all the software that we use. This is very useful for long-term maintenance and also for sensitive sensitive software. GUIX is also similar project, but a little bit different approach. uroot I already mentioned. Nix is very popular recently, gaining a lot of traction, even in some serious applications, despite there is some criticism from StageX in direction of Nix. But anyway, this is very interesting. We should watch what's going on with this OS and probably think how we can leverage. There are many people who wants to leverage Nix and replace Yocto, and we will see how this will go. I think BSD ecosystem also getting traction recently. So OpenBSD and FreeBSD and probably other BSDs will get back to us, especially in context of embedded devices, firewalls, and so on. But anyway, let's move on. Of course, we have this ecosystem. Now we have to somehow exist in an environment where we build synergy between Zarhus based solutions and Dasharo to get some bigger value. And this is kind of pipeline of Dasharo and Zarhus release process. So we just extended this area where we just got this community. So what happened between Zarhus development team, Zarhus team, and the community, OEMs, enterprise, and users. So we know that we produce Dasharo toolsuit. There will be status today. There is product which is called Zarhus provisioning box, which doing very good. We should use or using even sometimes in our hardware lab validation for Dasharo and also for validating those components standalone. In our lab, we have our validation framework, we have tests, we have reservation system, and we have our controller, which is open source hardware remote testing environment controller. As the output from the lab, we're getting some version of Dasharo toolsuit, which we can call production. We're getting Zarhus provisioning box, of course, when validated, somebody is validated, gets into production, and we have some Dasharo. And now what is kind of new, or maybe new, not new, but as a concept was living in our processes, but in practice we didn't structure it that way, is just that Dasharo and DTS should be signed, or at least hashes of it should be signed by Zarhus provisioning box before pushing that to the audience, and just for the proof that it is delivered by 3MDeb. The same thing is, if there is new Zarhus provisioning box, we probably should deliver that to some customers, and we have already deployments of Zarhus provisioning box. So we should update our customer with the new version of the operating system, and then our customer could, I don't know, whatever, provision the binaries with some root of trust and chain of trust technology and publish on their server for their end users, or they may just publish on our server. That's completely fine. And then we have our deployment server where our customers can log in and get the update. There is also some new concept, or to some, it was always with us in some form, but it's not implemented yet, the attestation part. So we would like to also have situation in which our customer can inquire with some evidence from gathered on the platform, inquire if my platform is and firmware running or software running on my platform is trustworthy. And then we like send back decision, or at least some confirmation or some proof that okay, those hashes are okay. Of course, there is some limit to trustworthiness of that, but then it's decision of the community, OEM or enterprise or end user to trust or not trust. So what's the state of these components? So quite a lot is ready. As I said, the Zarhus provisioning box concept is kind of not fully implemented. Some kind of informal process exists, but it was not introduced fully. We have deployments of the on the customer side. The deployment and attestation server are probably more in progress thing or a concept thing, and attestation part is not ready despite the deployment is ready. So you can see that the ecosystem is quite mature, and we have to push that forward to complete the loop and just like speed it up. And of course, this is associated with something that I proposed on Kube's OS Summit this year, where we explore essentially this box. This box, where we would like to have system for. So this is essentially the composite Zarhus provisioning box, to which there is something that coming, some build that's coming, and then we can have a very highly divided workflow between VMs, which every VM is specialized in doing specific thing for the purpose of achieving the binary of Dasharo or whatever operating system, could be also Zarhus. And this binary is provisioned with the root of trust artifacts or chain of trust technology of the choice of the customer. This, of course, have to work with some HSMs, which should have structured key tree. But that's one thing. And of course, I would really like to extend this through these sites, through distributed reproducibility, where we can have very strong proof, ideally with StageX or GUIX, claiming, okay, those are builds that we did, or maybe there are some third parties that did also builds from this source code, and really this hash express that this is this source code. And in case of any problems, vulnerabilities or whatever, we can quickly get into what version was used and which version we have to change and update to mitigate the issue. This would be very important in light of the compliance, which coming very fast, and we will even talk a little bit today about that. Okay, that's one thing. I also wanted to show you, okay, so we have this ecosystem, growing ecosystem, then we have releases, and then we would like to somehow monetize that, sometimes have some business model for that. So we already discussed that, so I will not repeat the community part. The community part, we will have some Zarhus community releases. There will be probably some Zarhus Pro package at some point where you can just get Zarhus for, I don't know, it would be Zarhus WRT or Zarhus BMC for your platform, and then you will get regular updates. This would be a little bit different to the model which is normal on the market right now, where essentially you're getting your operating system or you're getting your BMC with the board, and you're hoping that your vendor will deliver some updates. No, our point is to decouple from that and have like kind of separate stream and separate ability to request features, have community for that, and so on and so on. Then, of course, there will be something for business clients, which we discussed. And the new thing here is really here. It's this Zarhus ecosystem alignment, and I will show you on the next slide what it really is. But first, I have to introduce new term, which is Zarhus hardware certification. I mentioned on the previous slide. Maybe not new; it's just a formalization of some existing processes or some existing steps. It is not on this slide, but essentially every Zarhus community support, Zarhus support package, Zarhus Enterprise Edition, every approach, every business approach will be with the goal of achieving Zarhus hardware certification for given platform. That's essentially our ultimate goal, because if there is this certification, we can say this is verifiable, it's trustworthy to some extent, of course, with given evidence, with given report. So this is a modus operandi that we have to achieve the certification. And of course, to drive to that certification, we have to consider a couple of things. First of all, we have like quite rich ecosystem. And this ecosystem got so many components. We have kernel, we have our rootfs, we have all the libraries, crypto libraries, and everything moving at some pace, delivering CVE fixes, and so on and so on. So there is a need for tracking all of that, and we have to propose to our customers structured way of essentially tracking that progress, but also tracking and aligning the roadmap of customer with what's going on in the public. And of course, not every customer wants to be known, wants to contribute as a let's say some company X wants to do fixes for something, and not always is the situation that they want to do it themselves, because they don't want to be exposed in a way that they really have this business direction, like don't want to reveal. So they coming to 3M Dev, to Zarhus team, and essentially say us to do this. We're doing that for them, and they are protected thanks to that. Do not leaking the information. Very quickly, this is something that's going monthly. So we have monthly calls with customers, typically 90 minutes. We're setting up progress, priorities. Of course, we have also our weekly meetings where we're planning Zarhus weekly meetings, and we also have Zarhus team always create pull requests, issues, create documentation, which essentially contribute to moving the roadmap further. Like three weeks before end of quarter, we should take all these integrations, all the fixes, analyze those, take the feedback from the team, and essentially start create the plan for the next quarter. There are more details here. I don't want to. I know I have little time, but that's essentially where we're going. We're going to the meeting with some input, with some strategic input that should align the roadmap of the customer to the goals, to the business goals, and then of course we drive it and we deliver solution. That's one thing. Of course, there's more to that. I guess we could improve also this area in more details, but that's not the point of the presentation, to show all possible details how Zarhus team operates. There is one more thing that I want to like. There are two last slides, I guess, maybe three. Zarhus pre-compliance report. So Zarhus hardware certification have to start somewhere. So let's say customer got some platform, and that platform, we really don't know it. It's a completely new platform. And what customers should do with this? So essentially, customer coming to us and have inquiry, oh, Zarhus team, please check this platform. Is it trustworthy? Is it good? Is it like, can root of trust be delivered? Can chain of trust technology could be delivered for that platform, maybe upstream it, and so on. So that we have two phases. First phase, we can say, even without hardware, we can do something. So we're taking data sheets, we're taking BSP code, we're taking various stuff, we review that. Then we trying to map whatever we will find to the Zarhus hardware certification requirements, because we know what we want regarding root of trust and chain of trust. Then we identify, okay, how's the boot chain look like? What are the gaps? How the chain of trust passing between the boot phases? How to secure those? And of course, this is related with trusted execution environment, trusted firmware ACE, trusted firmware M, maybe OPTI, with TPM, with FTPM, with measured boot, and so on. It can be related with bootloader, and so on and so on. We have some gap analysis, we have feature matrix tests, we have boot components identification, we have false readiness, because we know what kind of state is in upstream, what's the silicon vendor got, and then in some way we can deliver to customer, okay, here is the report, here is the state of this platform, here are our recommendations, and typically here is the price for fixing that. And the next stage is with hardware. So when we have hardware, we can essentially verify, because sometimes documentation saying one and reality saying something different. So we have to verify our assumptions based on the documentation. And this is what we're doing in P2. I will not go into details of that because that's quite a lot of steps. It's even more like, of course, we assemble the device, we have to validate it, we have to run full cycle. And then, of course, there are probably some gaps. If not, then platform is ideal, but we didn't find any ideal platform yet. So maybe at some point. And then that's also a good validation for customer that this is good selection of hardware and everything works. And that's essentially our modus operandi for pre-compliance report for Zarhus hardware certification. And that's it about the products. I think I will get back to products in the future presentation, maybe next quarter. About the community, not much changed. A couple people joined, like more stars. 2 people joined the Matrix. No traction. We do not publish much. I guess at some point we will publish Zarhus BMC or Zarhus OpenWRT or some reference binaries for other platforms, and then it will hit the public audience, and maybe that way we will gain more traction. Right now we're just operating, let's say, in this kind of hidden way, or maybe small audience way. Okay, that's it for me. Sorry for taking too much time, as always. I guess I don't know if we have any questions. Okay, let's switch to Mateusz. Yeah.
Hello, please give me a second so I can share my screen. And you should be seeing the presentation now. So, hello, welcome to the Zarhus Developers Meetup 3, first part. And what I'll be presenting today is context-based authentication, so identifying host by the environment. And what I have here is something to cheer you up. It's the picture from my ad hoc testing, very early stage, and I consider it a totally normal computing. So about me, my name is Mateusz, and I am a former system software development engineer at Intel. I like to say that I used to develop MDEDM utility. And currently I'm the junior embedded systems developer at 3MDev, and I'm the member of Zarhus team. And here are some medias that you can check me out, and yeah, let's proceed to the presentation. So location-based authentication. The first thing that comes to your mind when talking about location-based authentication is geofencing. It is the classic mechanism we know from like streaming services, where those pesky greedy corporations, these allow you access to the show that are available in the other countries. But there are issues with this technology. First of all, it relies on the data like GPS and cellular information. And not only you have to have dedicated hardware to just use it, I guess. And another thing is these are easily spoofable. Importantly, the GPS is very spoofable. So that's when the CBA comes in. And let me briefly to introduce you to the concept of CBA. So CBA stands for context-based authentication. And basically, it relies on finding anomalies in some user patterns. It's classically used to authenticate users. And anomalies could be like logging from other device, logging on non-standard time or from different location. Yeah, and that's basically what the classic CBA is about. And we will talk about the different use for CBA, but let me first introduce you to the concept of the RFF, which stands for radio frequency fingerprinting. So basically, no manufacturing process is perfect. And when you produce the Wi-Fi chips, each chip has some, is just not perfect. So by those imperfections, we can identify those chips. These are so unique that basically they are like the fingerprints on your fingertip. We can identify each device by some physical signal characteristics it transmits. And yeah, the implementation of CBA I be talking about uses those RFF information to basically identify unique hosts. And it's not about authenticating users, but authenticating device to device. And yeah, this technology, or rather the implementation, was not built in-house. It was delivered to us, but I will talk about it later. But when I first received it, I got a chance to review it. I had two questions. First question was about the probing resolution. So the question was that, can I use the device I want? Doesn't it need to be like some high-end device, so the data it fetches have like high resolution? And the answer is yes. The more higher end devices, generally speaking, deliver more detailed information. But we have some mechanisms to work around that, and one of these mechanisms is the machine learning. And machine learning is not necessarily used to compensate for low resolution, but rather to figure out the unique characteristic of the device that performs the sniffing. And based on that, we have some certainty that the data we are receiving are more or less enough resolution or appropriate. And the second question was, why not use stuff like MAC or IP, etc.? And this is quite a simple answer to that question, because those are easily spoofable. That's the first thing. This shouldn't be an issue in the dense environment, for example, in the data centers when you have a lot of devices, and it would be very hard to reproduce that environment remotely for somebody to access. But in less dense environment, that's always the chance. So that's one thing behind not using it. And the second thing is that those are cryptographic based. So not every device, because the solution I'm talking about mostly targets like low-end devices. These are cryptographic based, so each device have to have like some higher end computing power to process cryptographic operations, while analyzing physical signals is much less computing hungry and can be offloaded to other devices. Yeah, and now I have to introduce you to the CrossCon project. The CrossCon stands for Cross-Platform Open Security Stack for Connected Devices, and it is a project we are collaborating on with various other universities and companies to develop some secure solutions for connected devices. And the main product of the CrossCon is the CrossCon Hypervisor. Yeah, and before we discuss stack, let's talk about CrossCon. So CrossCon is a very lightweight hypervisor that can run both on devices like Raspberry Pi or even on the MCUs, so basically microcontrollers, and I think that's really cool. So during our testing, we had the chance to run it on LPC Espresso 55S69, I believe it was, and RPI4, and the demo I will be presenting today will be running on the RPI4 platform. So yeah, hypervisors. That's basically the stack that will run on a single Raspberry Pi in our demo. So let's start discussing it from the right. On the right, we have a Linux-based VM. It is a custom build-root-based Linux distribution, and we will be running the TLS client and TLS server on two devices. And I will talk about that thing later. But yeah, the first VM to the right is the build-root-based VM to run the TLS applications. The VM to the left is basically OPTI-based VM. It is the trusted execution environment, and it hosts the PKCS11TA. And that application is used to store private keys for the TLS client and TLS server that we will be running. It is the secure environment to store the keys, and we have not have direct access from outside of it. Yeah. The second VM to the left, it's also OPTI of TOS-based VM, and it's running the CBATA. It is the custom application that will basically gather the CSI, which stands for Channel State Information Data. So it's the information about the physical capabilities of the signal and sends those to the another entity I will talk about on the next slide. And yeah, it will basically do that. Yeah. And the last VM, the further to the left, is just yet another Linux-based VM, and it is used to maybe differently. Let me say differently. It's the OptiVM that will fetch the CSI information uses the Linux networking stack because it was hard to implement the driver for custom firmware Wi-Fi chips, and it had to be implemented in the Linux because there were some issues in OptiOS, but we are not responsible for it, so I cannot give details why that was. So what you are seeing here is the more refined hardware setup I presented you at the, I believe it was second slide. Yeah, and maybe let's start from discussing the demo I will be presenting. So the demo is basically the TLS based message server. It's just a server and a client, and they both exchange a single message over TCP socket. And what it's supposed to showcase is using the context-based authentication in some practical solutions as a second factor authentication. So first factor is done via TLS handshake. And once the TLS connection is opened, or rather TCP socket over TLS is established, the server will be verifying the client's authenticity based on the context-based authentication. And if the second factor authentication succeeds, then the message will go through from both ends. Yeah, and maybe let's quickly discuss the setup you're seeing. So this is my work laptop, and on the top of it you can see two Raspberry Pi 4 8GB version. And each of the Raspberry Pis is running the stack I showcased you in the previous slide. And they are connected via Ethernet cables to my PC. And also they are getting power from the PC. Yes, I am amazed too that it worked, but it worked. And yet another thing is the UART adapters, because we don't want to rely on visual information, rather we just use the console. Yeah, and that's basically it. Let me also discuss the role that laptop is happening, that is being, what's the laptop doing? So first of all, it serves as a router, and basically you host the DHCP so that both Pis can communicate. And it's a common network between the Pis and the computer. The second thing it does, it serves as a common certificate authenticity. Sorry. Yeah, it basically is a common thing that gives the certificates, or other provisions, both the Pis. And yeah, and the final role it performs is it hosts the machine language server I talked about previously. The machine language server is used to, the client will send enrollment to the machine language server, basically gathering the context-based information around it, the contextual data, as an enrollment. So the machine language model will install some initial fingerprint of the client, and then it will be used for verification. So if the client proves that by sending the contextual information to the machine language model, once again, that its position or origin did change, then the machine language model shall grant it the signature it can use to verify against the TLS server. Yeah, so that's basically it. And I think we can proceed to the demo. Yeah, exactly. So let me switch tabs to, I believe, yeah, I don't have it open. So let me quickly open it. Yeah, and I think you should be seeing the video. So what you are seeing is the setup I discussed in the office space, because this is where we will be performing the enrollment and the initial verification. Let me grab a chair so I can sit and show you the videos. And yeah, unfortunately, I cannot show it to you live because, as you can see, the setup is barely mobile and I don't really want to risk it breaking. So we will have to just do with the pre-recorded videos I have. Yeah, so initial enrollment, the office space. And now we'll switch to the command line. So on the left, I believe you can see the output from the TLS client, and on the right from the server. Oh, it will become clear later. But what we are doing here now is basically triggering U-boot to boot the Crosscon hypervisor, because unfortunately it isn't that production ready, and there are still some tricks that have to be done to launch it. And yeah, you can see that the Crosscon hypervisor is starting and that the Linux build-root VMs are already producing output. And what I'm doing here is basically booting both devices you saw and logging in. And I believe in this video we'll also request the IP addresses from the computer which serves as a router. And yeah, that's basically what I'm doing. Let me fast forward a bit. And yeah, you can see that we successfully obtained the IP address from the computer. Yeah. So let's go to the next video. And what I'm doing here is logging via SSH. Why? Because there's a known bug that the serial can hang after a while. So that's one inconvenience we have to work around. And yeah, I'm copying the IP addresses and I'll be pasting them into the simple build system, because not exactly for building, but it is one of the steps that is being done, but we have to provision the pies with the certificates. And it is basically what I'm doing. The application TLS client and TLS server gets recompiled, flashed to the pies over SCP, and also the certificates are being generated and both of the pies are being provisioned. Yeah, and it is exactly what's happening and it succeeded. Yeah, so let me switch back to the terminal. And on the top, on the window at the bottom, you can see that I'm starting the machine language model. And it says that it's listening. And on the left side, I'm starting the server. And on the right side, I'm starting the client and connecting to the server by its IP. Yeah. So now enrollment happens. So you can see on the server side that there's some activity happening already. And I believe, yeah, and now just to fast forward, because it takes like a minute and a half to gather those informations, you can see that we successfully enrolled. The server outputted some information and the first factor succeeded between the both nodes. So now the TCP socket is opened and the server will have to be verified if it changed its location. Yeah, and you can see once again the office space, and just to prove that I'm not like I don't know, that I'm not faking it. That's the word for I was searching for. Yeah, so the enrollment was done in the office space. And there's also a close-up on the pie, because when it fetches the CSI information, it just displays some LED pattern. Yeah, and I think that we'll be seeing exactly activity on the machine language model. We get the signature, And we can see on the server side on the right that the authentication succeeded. And the classic use case would normally end up here, but I had to modify the code to do some sanity checks. And the modification was to do the verification 3 times in total, because for the second verification, I have to switch the context, so location, to prove that when I switch location, the verification is no longer possible. Yeah, so basically what I'm doing here is launching yet another verification, and it's taking place. And I believe the next video, no, not this one yet, this proves that when I switch location, the verification was no longer successful. It was some mockup we did to showcase, I mean, not exactly showcase, it's just how implementation is done. And on the server side, you can see that the verification failed. Yeah, and where I went to the office kitchen when it's basically on the other side of the building. And why there? Because that's where my Wi-Fi bars dropped out to 0, and I knew that I shouldn't be getting any contextual information from the devices in the office space. So yeah, the second verification failed. And now I believe we are proceeding to the final verification that is being done in the office space once again. Yeah. So I just type here to perform it. And on this video, we should see that it succeeded or not. Yeah. So as you can see, I went back to the office space and the verification was successful once again, which proves that context-based authentication example is indeed working. Yeah, and sorry, wrong thing. Yeah, this is the video I was looking for. Yeah, and it's once again office space, and it succeeded. And as a final confirmation, the message I was talking about. So the demo is really basic, but its aim is to showcase the authentication, not to do fancy stuff, and just to prove to you how the what's the current state of the solution. And I mean that it's very, very early stage, basically just proof of concept. We've got a beautiful segmentation field at the end, but we can see that both server and clients received the information, sorry, the message. Yeah, and that's basic. That's some logs I just have in this directory, and that's basically it for the demo. I'm really sorry that I couldn't show it to you live, but as I said, it's barely mobile. And yeah, if you want to learn more, I left some references. You can take a look. References to the what is the CrossCon project, the build system if you want to reproduce the demo, although I don't know if I recommend it because it will take like a day, but you can, so if you want to. And yeah, that's basically it from my presentation. And I think that we have 2 minutes left, I believe. So time for questions.
Yeah, I was just wondering, like you're saying, this is that to build that is 1 day, but is there any publicly available image that could reproduce that, or someone who wants to reproduce have to do everything from scratch using some procedures from the links?
Sure. So there is the README prepared that showcases how to reproduce the demo I just did, although not the part that with 3 times the verification. But yeah, the README is linked in this presentation, and I believe the management will find a way to give it to you.
Mm-hmm.
And unfortunately, there is no public image that can be easily downloaded. Yeah, because it's basically complex process right now, whole provisioning, etc. And you have to have the Pi 8 GB version. Yeah, it's very early stage of development.
Mm-hmm. Okay, so I guess like one improvements which it needs is like a way easier provisioning.
Yeah, exactly. And the build system could also be made much more user friendly, in my opinion.
Mm-hmm. Okay, cool demo. Like, what's your kind of like what can go wrong?
What do you mean exactly?
What can go wrong in terms of like while leveraging this kind of methods? Like, what are the drawbacks of leveraging those context-based authentication methods?
I don't necessarily think of drawbacks right there, but it's definitely makes the solution more complex. And I think the scalability might also be the issue right there, because as I said in the beginning, we are targeting like more IoT based stuff, and there isn't really, for Crosscon at least, solutions for like more mature platform like x86 and so on.
Mm-hmm.
Yeah. So I think my answer would be to maturity of this solution and complexity.
Okay. Okay. Thank you very much.
Thank you.
Yeah, I guess next is Daniel.
Yep, I'm next. Give me a second to share the screen. This is one. Do you see the screen? Okay. Hello, everyone. Welcome to the Zarhus Developers Meetup, and now is my part to present you. I will present Dasharu Tool Suite Development and Testing Insights and Roadmap. Who am I? I'm Daniel Klimuk. I'm Zarhus team leader.
I'm not sure,
and
but
embedded
slides do not switch, so I guess
slides on
like
the switch.
that's. Oh, now it's okay.
Interesting. Let me know if they will switch in future. My name is Daniel Klimuk, and I'm Zarhus team leader in FreeMDep, and I'm a bit of embedded Linux enthusiast. The agenda of this presentation, just let me check if slide switched. Yep, it has switched. The agenda of this presentation is as follows. Firstly, I will introduce you what is the Dashara tool suite. Then we will talk about where the Dashara tool suite is located in Dashara universe. Then I will update you on the Dashara tool suite status. I will give you some development and testing insights of Dashara tool suite, and then we will discuss the Dashara tool suite roadmap and future releases. This presentation will introduce you briefly into some technical topics and reports, and for full deep dive, I recommend you to monitor the blog.freemdev.com for a blog post that will cover all these topics in depth. I will call Dashara tool suite DTS just for convenience from now on. So what is DTS? DTS is a bridge between you and Dashara. Initially, it was built with two main goals. Here. The first goal is to support end users while deploying Dashara firmware, and the second goal is to support Dashara firmware developers while they're developing Dashara firmware. But what is DTS from the technical point of view? The DTS is a Yocto-based Linux distribution with tools supplied by Zarhus and Dashara teams for all the tasks it does. The main idea of the Dashara tool suite for the client point of view is Dashara zero-touch initial deployment. that consists of a list of automated workflows. Here are the workflows. That is the initial deployment, update, and transition for the Dashara firmware. Then we have an important feature that is called Dashara Hardware Compatibility List Report. Shortly, it is DTS HCL, as we developers call it. This thing supports not only developers when they develop the Dashara firmware, but help us get feedback from clients as well. And then we have a new feature that was added in the latest releases, a fusing workflow for some of the platforms that support the Dashara firmware. And then we have an important workflow that is firmware recovery workflow. And on the left side, you can see the main menu of the Dashara tool suite. So, where the Dashara tool suite located in the Dashara universe and what it provides. This is a copy of the diagram Piotr presented you, and as Piotr outlined, the Dashara tool suite is located in two distinct places. The place here outlines the role in the development process of both the Dashara firmware and the tools that are provided by Zarhus team, that is Dashara tool suite itself and the Zarhus provisioning box. Then here we have a role of Dashara tool suite to provide support for clients, especially the deploying support of Dashara firmware and some of the security features that will be added lately and will be related to Zarhus provisioning box. That is from the introduction, and right now we will jump to some latest releases and statistics. This is a map of releases since the second edition of the Zarhus Developers Meetup. As you can see, we had quite a lot of releases lately that added a lot of new features and that is more important, a lot of new firmware for some of the platforms. There is really a lot to discuss. I recommend you to check the releases page and follow the releases to be up to date about the test releases. Yes, and here are some statistics. Data issues. We since the second edition of the ZDEM, we had quite a jump in the issues here. Most of the issues are related to the enhancements and some future requests because of we are doing some major changes in the test. I will mention it later. But some of them, of course, bugs that we have to fix. And here here are some statistics about the main DTS repository pull requests. As you can see, we had a jump of pull requests here after the latest the DEM edition as well. This proves we had some new features, and maybe some bug fix. So there is a lot of activity actually. And here is the repo that holds all DTS logic. And here we have a jump in the activity as well. And this is a new repo this is without S. This is typo, sorry. This is a new repo. It was added around half a year ago. And the purpose of this repo is to keep all the metadata that currently is built in Dashara tool suite separately for some convenience in releases and all the other organization stuff. We have been experimenting lately in this repo with this repo, but right now we are implementing something that will finally get into production. So we have even some open pull requests here at the beginning of this month. And the last slide from the statistics part is DTS contributions. DTS is an open source firmware, and as an open source firmware, it uses other. It is an open source software, sorry, and as an open source software, it uses other open source projects. And while we are developing DTS, we are developing the tools that we use as well, and we really like to contribute to these tools. Since the last edition of Zarhus Developers Meetup, we had one contribution that was authored by one of the Zarhus team members, Michał Iwanicki. The contribution was to Flashram project that prevents you from some platform breaks during firmware deployment in the DTS as well. So really big thank you to the contributor here. For more information, you can check the repos and links here. And now I want to give you some insights about latest changes in the DTS and most global changes in the DTS that happened since last edition of Zarhus Developers Meetup. And the biggest changes in the DTS from our point of view is a new testing methodology. We call it end-to-end testing methodology. And before introducing the general concept of the methodology, I want to outline some challenges that we as developers face. The entire DTS logic and code can be divided into two groups. The code that is not firmware or hardware related, it consists of some general code like some UI, remote data access, etc., and the code that is related to firmware and hardware, and is firmware hardware specific, like flash ROM, DMA decode, calls, and all the logic that is related to these tools. Currently, and because of the architecture, of the DTS architecture that is a monolith architecture, we have all this logic and tools in one place without strict rules and etc. It's one big piece of code, and lately we figured out that during the periods when there is a lot of changes and releases, it is really hard to add new features and to maintain this code. And we wanted to make it easier for the developers, make it easier to add features and to maintain stability of the entire code base. So the idea is simple. We want to move on something that looks like a microservices architecture, but maybe not quite a microservices architecture. But the idea is to separate this. Oh, it is the same color. Okay. The idea is to separate those chunks of code and minimize them separately. So ideally, we would have all these general code blocks as simple and minimalistic as possible. For example, this would be an UI. Here we have some server, and etc. etc. And here on the and here we will have all the custom hardware/firmware workarounds and all the stuff. And of course, there are other changes that hide beneath all these diagrams. The changes are described in the blog post I mentioned before, or will be described. Yeah. But before making all those global changes, we wanted to develop a testing methodology that will help us keep the entire code base together and stable. And this led to development of the before mentioned end-to-end testing methodology. And behind the end-to-end testing methodology, there are two key concepts. The first concept is a black box testing that actually bases on treating the data as a black box without caring too much what is going on inside during testing, but caring a lot about specified inputs and outputs and their correlations. So even if we will completely refactor the data's code inside, there will be no changes in the testing methodology, and we will be able to just operate on the same inputs and outputs with goal to test the test and all the changes. And the second key concept behind the end-to-end testing methodology is use case testing, is when we test not all inputs and outputs of the DTS, but some sets of inputs and outputs. And there are two groups of these sets. The first group is called success path. The success paths are outlined as smiling face here. And the second group is the same color. And the second group is the error path that is outlined by skulls here. The key difference between the two groups is that the success path is a path we want to keep. We want to maintain this path. Let the users that use the DTS to after they select the workflow to the correctly updated, modified, and expected firmware state. And the error paths are the paths that we want to monitor, to have a list of these error paths and to check them every time that they are properly handled and communicated to user, because the error paths are the paths that could actually break your platform. And yes, and this actually is a second concept. To test all of these and group into one piece and yes, and test it quickly, we developed two additional testing architectures. Here is architecture that was present for some time. It's just testing on hardware. The problem was that testing on hardware took us a lot of time. It was hard to automate it. Yeah, and it slowed down all the releases and development processes. And therefore, we decided to develop two distinct architectures that allowed us to fully automate the testing process. This is because of with the help of Camel and OSFV. The architectures are pretty complicated, so be sure to check the blog post I mentioned before. Yeah, the key idea of this architecture, as I mentioned, is to remove the dependency on hardware from the development workflow. Because yeah, the standard testing and development workflow looked before the changes look like this, that we do some changes, build the test, prepare hardware, which by itself, if done one time, takes around 90% of developers' time, and then launch OSFV, that is a testing framework in the Sharo universe, and hope the hardware will not cause any problems during testing that will cause false positives or false negative. But the probability that hardware cause the problems is quite high, and therefore the developer should detect these problems, that the hardware was the reason to cause these problems, and get back to hardware and start all over again and lost time and all the things. And with the new testing methodologies, we're able to delete, to get rid of the hardware here and free all the 90% time that was spent on hardware configuration and solving of problems related to hardware for the actual development by the mocking system that was implemented in the test. Yeah, and for more about the testing and how all of the systems and subsystems were implemented, I'm again redirecting you to the blog post. And that's it about the development and testing insights. And the last part of my presentation is the DataS roadmap. So what is coming next in the DataS? Currently, the next planned release is this one here, and the key features in this release are the separated user interface that will be shared between other Dasharo and Zarhus projects, such as, for example, the Zarhus provisioning box. The idea here is to at least to make the user interface more stable, more documented, yeah, and share between the projects. Then the second key feature will be the full transition to the metadata that is stored separately, and that will actually increase the frequency of the DataS releases and Dasharo firmware releases. Yeah. The third key feature will be actually sharing the results of the tests that are based on the new end-to-end methodology in OSFV dashboard. This is a technology used by the Sharo team to share the results of the Sharo firmware testing. And there are, of course, some minor fixes for some bugs, and etc., etc. For more information, check the linked milestone on GitHub. For the future releases, we have some ideas what to do next. The most important ideas are the ideas related to the Sharo universe and integration of the DTS features and DTS itself to the workflows described by Piotr. For example, the root of trust and chain of trust, verification and attestation, maybe some sharing of the details features with the upcoming Zarhus BMC and etc. etc. And of course, there are a lot of new firmware for already existing platforms or new firmware that will be added to the list of supported hardware soon. For example, the servers, and some desktop platforms such as Nova Custom laptops and all the other. And that's it from my side. Any questions and maybe topics to discuss?
I guess we are 2 minutes behind the schedule. Yeah, I guess like maybe one short comment. Like I think the one value of the black box and adding the logical blocks like UI is creating new black boxes. Like we have just one, and thanks to the division, we can create more. Yeah.
Yeah, I believe it is called unit testing. When we will clean up the code base enough, we can test not the entire code base, but some features or functions separately.
Yeah. I imagine also like authentication module or some attestation module or something like that.
Exactly.
Okay. That's it. So I guess next one is Maciej. We are a little bit behind the schedule, but just in case, we will just like make it a little bit longer. Maybe my presentation will be shorter than the final one. So Maciej, stage is yours.
Slide switching.
Works.
Okay, so hi, today we will talk about hardware-based security in Android. The agenda for today will cover 4 topics: trusted execution environment, verified boot, and root of trust, which is involved with this process. We'll take a look at the encryption mechanisms in Android, and lastly, shortly, we'll cover upcoming virtualization extensions to Android ecosystem. So let's start with the trusted execution environment, which is TE. Trusted
Okay, there are some audio issue, yeah? Or this is just me?
Okay, is it gone or not?
Yes, right now is better.
It's better. Maybe I will be closer.
You can start slide from the beginning because it was.
Sure. Okay, so let's start with a few words about trusted execution environment. It is a dedicated separate trusted execution environment, which is separate from the main operating system. Nowadays, basically all the devices running Android are running on ARM, so they often utilize this ARM trust zone, which is a hardware feature thanks to which we can create this hardware-backed isolated environment. It is used for execution of confidential operations. We'll talk a bit later about what are those specifically in this Android ecosystem. In this Android security model, the main operating system, the Android, is considered untrusted. So the critical operations involving some key operations, signing, encrypting, and so on, those are handled by this trusted execution environment. The trusted execution environment itself also, maybe you can say that it is provided by the trusted operating system, which is a small operating system provided by the hardware vendor typically. And on top of that operating system, we can run some trusted applications providing specific critical security services to the main operating system, which is in our case Android. So it is a pretty standard way, and Android heavily relies on this ARM feature. Then the next component we will talk about is Trusty. Trusty is like a specific implementation of a trusted execution environment. Google has noticed that many vendors provide some form of trusted execution environments and operating systems and trusted applications, but only in the form of binary blobs. So they went ahead and created like an open source implementation of a secure operating system. Currently, it mostly is running on Google Pixel devices. Goal is to provide some reliable and open alternative. Google say they would probably want other vendors to switch to that. They want to improve transparency and reduce fragmentation of the ecosystem, and also simplify development of trusted applications. But what might be worth noting here is that it's not global platform compliant. There is already existing standard for trusted execution environment, and ironically, most of the vendors follow that. So the Qualcomm, Samsung, and so on, they use their own proprietary trusted execution environment, but they are compliant. So it's actually possible to develop applications being portable using those APIs. But if you wanted to create application for Trusty, you need to follow Google APIs. So here we have a couple of examples of trusted applications we can use in Android. So as we said already, we use them for critical security areas, such as lock screen passcode verification. So whenever we provide a PIN or a fingerprint, so the biometrics or the face unlock with the camera, there are dedicated trusted services for each of those actions. And the matching of either the fingerprint or the camera image or the PIN or the passphrase is actually being made in that isolated trusted application. And the main operating system merely receives a message that whether the authentication passed or failed. So that's how it looks like here. The other use case beyond authentication is key storage and key management and basically all of the cryptographic operations. So the keys in the Android ecosystem are never exposed in a plain text form to the main OS, rather than that they are stored as blobs in the file system, and applications can use specific keys via specific trusted services, which provide crypto functions to the higher layers of the system. Another possibly interesting use case example is protected confirmation. Android has this trusted user interface for some high assurance transactions. We can create our application in a way that it would call a specific trusted application for this high assurance protected confirmation. Maybe not so interesting, there is also use case for DRM to manage DRM protected content. So that was the in general. Now let's take a look at Android verified boot. Before we go to the Android verified boot itself, we want to have a quick look on the boot process. This is a modern ARM64 boot process, and also specifically looking from the Android perspective. Depending on the hardware vendor, it may be a bit. The implementation might be a bit different, but the general flow should look basically the same. So we always start with some form of primary bootloader, which is typically stored in a boot ROM in a read-only memory, which are fused directly into the SoC. And it is our root of trust. Typically, root of trust is also connected to some public key, which is fused to the hardware as well. We will take a look at a few specific examples in a moment. So we have this first bootloader, which verifies using this fused public key, the second stage bootloader, secondary bootloader. And here we may have also like many proprietary bootloaders. We can have trusted firmware A provides also this component. The ecosystem here is very fragmented. But the goal of this component is to set up a secure and non-secure world and define the memory isolation boundaries. So in the later stages, we have a clear separation, which memory is dedicated for the secure world and which memory is dedicated for the normal world. So this secondary bootloader also loads further bootloaders. We have a secure payload, which is trusted execution environment OS, so it can be trusty, as an example from the previous slide, or it can be some, for instance, Qualcomm or Samsung specific operating systems. And finally, we also have so-called non-secure firmware, which is some form of bootloader booting Android finally. So it can be U-boot, Linux, CDK2. It's also not standardized area yet in Android. We already mentioned root of trust, hardware root of trust. We want to talk about verified boot, but for the verified boot to be really functional, we have to start somewhere, and we need to root our trust in some immutable part of the system. Android defines some of the requirements that hardware vendors must follow in order to be compatible with this verified boot feature. And one important one could be the C1.3, which says that the device must start verification from an immutable hardware key that is a root of trust and go all the way up to the system partition. There are more requirements like that, and there are, as you can see, there are not very specific. There are some. This compatibility program covers like a lot of area of the Android compatibility. This integrity part is not the most important one, but it's the most interesting for us. There are also a lot of tests for the Android functionality to see if your device can be compatible with Android, but they mostly focus on like higher level features than what we are interested in here. So what we have is those text form requirements only. So maybe let's take a look at some examples how hardware vendors interpret that and implement that in practice. Some vendors publish some of the documentation in terms of the secure boot, verified boot. They call it their own way, differently. But essentially, the idea is generally the same, that we have a boot ROM, that we have some fuse, which is inside SoC, that during the manufacturing we fuse the public key, and that is our root of trust for the next stages. So we have those vendor-specific bootloaders, vendor-specific trusted execution environment. So it's very fragmented in this area, and then we jump to the Android kernel using this Android verified boot feature. We will cover a bit more in a moment. Another example is Qualcomm. They also have this primary bootloader in boot ROM. Then it loads it creates like secure world, non-secure world, and XBL sec acts as root of trust for the trust zone images, and the XBL bootloader as root of trust for non-trust zone images and verifies them later on. And we can also see in some documents from Qualcomm, we can read that we have similar mechanisms, that we have some form of fuses or maybe even hard-coded the key in hardware ROM code. Another example is Google Pixel. Here it's a bit different, as we have a separate security chip, which is Titan M. It's derived from the Google Titan chips originally produced for server boards, but we have also a version of Titan M, which is smaller and more targeted towards this mobile ecosystem. And in this case, this root of trust is provided by the external chip, which bootstraps the whole boot of the platform. So verified boot. So the Android verified boot now, what that is? Its main goal is to ensure that all executed comes from the trusted source, and by all code we mean the OS code. So we start verification from the Android kernel, then all of the partitions and so on, because that's what the Android focuses on. The previous part is more specific to the vendors. The important part is to establish a full chain of trust, starting from the hardware protected root of trust. Each stage verifies the next one. What is also important, we will see in the next slides, that the verified boot focuses on communication of the state to the end user. Just mentioning DM Verity briefly, it's like a Linux feature, not a hardware feature, but it's used to verify the partitions, to verify the integrity of the partitions. We'll see in a moment that a verified boot flow also has like a error code for that failure. An interesting feature is user settable root of trust. On some devices like Google Pixel devices, you can change the key which is used to verify the Android OS to your custom one. So you can run a custom OS, not only the OS approved by the hardware vendor. In this case, it is Google. So this path is used by the custom ROMs such as Graphene OS during installation, where we unlock the bootloader. We set custom key and we lock the bootloader back. It is a bit similar to the secure boot, UEFI secure boot, a custom keys mechanism. So there are a couple of boot states that can be reported by verified boot. So let's take a quick look on the user experience. We have a yellow one, which means that the device is locked with a custom root of trust. It will always appear if we have a custom root of trust installed. For instance, if you have a Graphene OS on each boot, you can see this screen. It proceeds automatically after 10 seconds, so it doesn't block your boot. But you have a time to compare this hash, and you may go to OS vendor, or maybe if you build your own OS, you may compare this hash to make sure that you are running the OS you wanted to run. And then we have orange screen, which means bootloader is unlocked, which essentially means there is no verified boot protection. There is software integrity is not guaranteed by verified boot. I mentioned DM Verity just a moment ago. So if there is a problem with integrity of any of the partitions, we can see a red screen. And by default, in this state, the device powers off automatically. But there is option for the user to bypass it and boot regardless. I mentioned that the bootloader area is very fragmented. Google also working on making it a bit more unified. So they're introducing this generic bootloader, which is essentially a UEFI application written in Rust, of course. So we can guess that it will be a standard in a few versions. Since Android 16, it says it's strongly recommended for ARM64, so basically for all Android phones. And we may guess it may become mandatory in the future, so we may have UEFI on all Android devices in a few years, which is a requirement for hardware vendors. Let's take a quick look at encryption. All user data on Android is encrypted using symmetric encryption keys, and we don't use full disk encryption, we use file-based encryption. So whenever application tries to get data from disk, it's encrypted, decrypted before passing to the application, and before when the application wants to write data to the disk, it is automatically encrypted before committing to the disk. So all of the user data is encrypted all the time. So why this switch to the file-based encryption? Because previously, when the full disk encryption was used, it was a problem that when after we boot the device, some of the services are not working because the disk is encrypted. So now we can have a specific parts of the system being decrypted automatically even before user enters unlocks the phone. So for instance, services like alarm or crucial system services can be already operational even before we unlock the device. So as a result, we also have like two kinds of storage locations with this file-based encryption. We have device encrypted, which is encrypted automatically as soon as the device booted and passed the verified boot phases. And we also have credentials encrypted. So those files are only encrypted and decrypted when when verified boot passes and also user unlocks the device. So that's recommended for most of the data, but if there is some specific service that need to be executed or access some data before screen is unlocked, there is an option to do that. So quick look at the hardware-backed key store. So as we already know, we have two ways of storing the encrypted files. So device encrypted and credentials encrypted. And of course, trusted applications are involved in this process. We have this gatekeeper trusted application, which provides authentication services to the Android, and we have this KeyMint trusted application, which is used for storing and managing keys. So keys never are exposed outside of the trusted execution environment. So we have like these two types of keys. So if you have the device encrypted key, then as soon as the verified boot passed, the KeyMint can release, not release keys, but can perform some decryption operations on specific files, and those files can already be available to some services that must be running even before the screen is unlocked. And for the others, we need this verified boot component to pass as well. But we also need a user to provide valid credentials, and only after both conditions are met, we can decrypt the credentials encrypted files, which are available only after user unlocks the device. And very shortly about the Android virtualization framework. We can say it also uses some hardware feature, which is a virtualization feature. It is quite a new approach in Android to provide an option for even more sandbox environments. So it consists of the PKVM hypervisor, which is a modified Linux KVM that we know. It provides MicroDroid, which is a minimal Android-based OS, which can be put inside of the protected virtual machine. And the goal is to provide a framework for developers to easily transition from regular applications to protected VMs. So that is why we have this Android API inside of this VM, so the traditional application can be quite easily transitioned into protected VM, which provides stronger separation mechanisms. So that would be it for today. Thank you.
Thanks, Maciej. Yeah, a lot of interesting stuff. Like, I guess, yeah, we are behind the schedule, but for me, of course, is the most interesting is this OTP fusing. You mentioned this is done on manufacturing floor, but that's kind of weird because in terms, of course, that's recommended, and of course, everyone should do that. But on the other side, you're buying chips from someone, like, and maybe producer of the phone is not the chip vendor. And what in that case? So someone needs a tooling for going through that process, yeah, I guess.
Yes, that's really not. Yes, obviously we know we use like those tooling ourselves, so we know how they look like roughly for some vendors. Yeah, but it's not something that Android cares about at all. They just say that we need root of trust, which is tied to the hardware, and then it can later be used for verified boot of the operating system. What is they care about mostly.
And so how they call the software? I don't know. Someone have to leverage this this whatever was fused, yeah. So there is like bootrom, I guess, that leverage that always bootrom expose that functionality.
No, bootrom doesn't need to expose anything. We have to pick a chain of trust that each component verifies the next one. So we start with the bootrom. Bootrom verifies the next bootloader, and the next bootloader may use some bootrom feature, but may also use its own verification functions, and maybe even a different key, maybe even stored inside the binary. That's totally up to the developer. For this Qualcomm, they say, I'm sure about the details, but they have this original root of trust, which is baked in hardware, and then they have two paths. And normal XBL is verifying the next stage. So possibly we have maybe a different key somewhere here, also here. So this one is possibly the fused key is possibly used to verify only those two, and those two can use some mechanism also to verify the next stages.
Okay, yeah, obviously like the code which to maintain the life cycle of fusing and so on, and like kind of talking with the fuses is the target of attack, because I guess like
it is, but it's like very fragmented, diverse, and it's not in this what Android cares. Maybe they care of their devices, of course, for their implementation, but for the vendors, yeah, there might be bugs here in this whole area on different stages of verification, and yeah, if there are, it's like a responsibility of a specific vendor.
That's interesting. That's interesting that there is that it doesn't sound like Google enforce any. Like I think it has to go in that direction, because it's like with Microsoft, yeah, Microsoft enforced on the OEM certain security properties, and like seems that Google will go that path, or maybe will dominate the market.
We can say they do. They do specify this verified boot flow, because this verified boot flow must be implemented in this OS bootloader, which is also provided today by vendors. So vendors must follow some guidelines from Google, or maybe also they have also this library AVB. They can integrate to their own bootloaders to load the Android kernel. And
yeah, I just wondering like what are the evidence of that vendors providing software can just fake it, yeah, and or not do the good job. So what are the really verifiable evidence? Yeah,
there are some tests in this suite I showed, but as I said, not everything is scripted in tests. So yeah, I'm not sure.
Okay, sure. Okay, like let's switch to Kamil, and thank you very much, Maciej. That was very interesting.
Hello, can you hear me?
Yes.
All right. Display, here we go. Can you see my screen right now? All right, so hello everyone. I'm Kamil, a junior embedded systems developer at 3MDev, someone who likes reasonable security. Some of you may recognize me from this year's Skips OS Summit, and expressing myself through writing documents. However, just a precaution, despite the fact that I will be talking about the ever-dreaded NIS2 and something that might sound bureaucratic, today we will not be filing any documents at all, and on the contrary, I would like to demonstrate you how you can unlock your digital sovereignty with Zarhus OS. So as an introduction, I will talk about, in short, what the regulatory requirements are, how the situation looks like nowadays, and what problems still kept arising despite all the mechanisms everyone wants to introduce to secure the world. and how to transform the ever-dreaded bureaucratic requirements into controlling your own hardware, your own firmware, and how to provision it securely. So, a very short summary about the NIS2 Article 21. It's about supply chain security and cryptography. So basically, you as a company have to assess the vulnerabilities of your suppliers, your providers, and assess how they themselves perform their developer practices. Are they secure enough? And how to mitigate potential risks that may arise from any accidental errors. And in the very case of cryptography, what can you do to do cryptography the right way? Because unfortunately, it's incredibly easy to mess things up, even no matter how hard you try. Well, it happens. So in the context of your firmware security, let's say that you got your hardware from a prominent vendor that does care about security, but first things first, can you prove that it hasn't been tampered in transit, that nothing bad happened to it? And also, can you rely on most likely closed-source security implementations? Because accidents happen to everyone, even the best can suffer sometimes. So here's a screenshot from CVE details about a vulnerability in the firmware of a prominent board vendor. And also, what happens when someone else takes care of key handling and revocations? Here's a screenshot that demonstrates that no matter what, even a legit Microsoft signed binary could be exploited if it's vulnerable, in the very case that it hasn't been revoked as soon as possible. So how can we even think about satisfying the requirements? Well, we could use open source firmware and also implement like a bunker when all the secure signing takes place that only the most trusted individuals have access to. It does sound simple, but Kamil, you might be asking, how much would it cost? How much work I personally would need to do to set things up, to not mess up anything on my end? Because I don't trust myself to do this the right way, because most likely other giants will take care of it better than I ever could. So what can I do in this situation? How can I satisfy the bureaucratic requirements? How much paperwork will be involved? How much can I trust the third-party vendors? Well, you might recall a presentation from Piotr and Daniel talking about provisioning box. Well, see the little gizmo on the right? This is the Zarhus Trusted Provisioning Box, into which you plug in some USB flash drives, and it automates all the stuff I talked about before. So let's get the meat of the presentation. How to fortify the supply chain? Well, after plugging the USB flash drive and booting the Zarhus OS, you simply run the Zarhus storage create command. You choose your flash drive that you plugged in. Then you set up a password when all the all private keys will be stored. All happens in a compartmentalized, air-gapped way, so it doesn't leave the so-called bunker I've been talking about earlier. Once that's done, you simply run the Zarhus prepare command to generate your Intel bootguard keys. Well, about bootguard, here's a curiosity. It enforces manufacturer-defined boot policies to block any unauthorized boot code, but since right now we're talking about you being in control of your hardware, you act like the manufacturer. So you block anything that you don't unauthorize and consent to run. So once that's done and your capsule gets provisioned automatically, you simply reboot, you go to the dash arrow security options, and you should see that the boot medium is locked and SMM BIOS write protection is checked as well. So the boot process has been guarded, but your way, not some third-party manufacturer way. Furthermore, you can also be in control of your UEFI secure boot keys, also by running simply one command. So as you can see here, it resigns the Zarhus OS binaries. So once you reboot, the provisioning box runs the signed images that only you control. So I've been talking about supply chain fortification. So see that thing? These are the digital chains that supply the fortification of the machines that you and only you own and control. So once that we're here, how can we liberate our firmware from third-party reliance? Well, it's time to provision the Dasharo firmware your way with the keys that you've just generated, as I've shown you. The steps are simple. You just download the firmware to your flash drive, you plug it into the provisioning box and mount it, and do the provisioning part. So how much work can be involved in these 3 steps? It turns out that it's not that hard as it seems. You simply run a few commands. You download the firmware with a script that the Dasharo team has prepared. You plug in the flash drive to your provisioning box and mount it. It's a matter of simply copying these commands because the labels stay the same. You provision the capsule, and once the capsule is provisioned, you just transfer it to your work machine and use FWUPD tool to deploy it, and you're in control of your machines. So in short, it may sound scary with all the bureaucratic parts and the reliance on third-party vendors, especially when we're considering closed source implementations that act like the black boxes that you can't inspect. But now that we have a way to automate this, do the signing in an air-gapped way with no way of messing up the cryptography part, and provisioning the trusted Dasharo firmware, we can be sure that all the ever-dreaded bureaucratic requirements are not as scary as they seem initially, because in practice, it's all the matter of using the right tools. So I'm not going to spoil everything, but as you've seen in the earlier presentations, when it comes to the UI decoupling and the Dasharo tool suite, I can tell you that only time will tell how the future developments will take place. So that's all I wanted to tell you right now. Any questions?
Well, thanks, Kamil. Yeah, I guess like there is very kind of minimal connection with NIS2. Maybe we can build some better bridge. So okay, let's say we got this provisioning, this secure stuff, secure supply chain, which is under our control. How this, like, let's say there is audit, and how this makes us like compliant, or how the compliance look like in this situation, how you would envision it, or how we can justify that our actions were enough to comply with the NIS2 requirements.
Well, now that we've got the open source implementation, I mean not only the Dasharo firmware, which can be audited due to its open source nature, but also the fact that we have an air-gapped machine which can't permit any key leakage. We could show this to the auditors that we are in control not only of the hardware, but also an open auditable platform that anyone in the world can audit. And therefore, we did audit the supplier, because due to its open source nature, anyone can do it.
Interesting. We'll have only to show and they will believe, or are there any some tests defined or verification procedures or whatever we should make sure our software follows, and they will check? Yeah.
Well, due to the nature that the most protected stuff out there that I'm not allowed to talk about runs Dasharo, it's a matter of proving that it's indeed used in practice.
Yeah, I guess like the part of the audit typically is okay, what kind of protection is expected from you? because like who you are in the, what's your profile of your organization, and based on that there is scrutiny added. And of course, if you are very high profile, then there is also very detailed scrutiny in audit, including, okay, where are the procedures for that, how I will reproduce this, how I will reproduce that. And I guess like that's the evidence that someone audited have to deliver to the auditor to get the really sign off. Yes, I checked that, I verified that's true what they're saying in this evidence, that evidence is correct. Yeah. Or am I missing something, Camille? Like, is it like maybe this looks a little bit different?
Well, also due to the nature of the provisioning box working completely offline, it's also way higher, way better protection that most companies can expect. Especially because it works pretty much out of the box. You just plug in the flash drive, you provision your capsules, and that's all there is to do. There is no manual intervention needed to set up cryptography properly, because it's set up properly out of the box.
Yeah, I guess like that's benefit, because if someone delegate that to external party or delegate that to some service provider, then that's kind of drawback and definitely lower level of lower profile. Okay, thank you very much. And let me share final slides. I have just like a couple slides more. Okay, so yeah, so 3MDEP will be at Linux Plumbers Conference in Tokyo, Japan, December 11-13. We are co-organizer of the System Boot and Security Micro Conference at Linux Plumbers. I don't remember which year it is. Like I guess we did that 5 or 6 years, 5 times or maybe 4 times. I don't know. Like it's really I don't recall I know that 1 year we didn't, but anyway, this time we get it, and yes, there is a micro conference there. There will be nice talks. The talks will cover topics related with trench boot, TPMs, HSNs, root of trust, confidential computing technologies, virtual machine encryption, and so on. First one was in 2019. Yeah, 23 is missing. Yeah, so we got 6. Yeah, I guess it's 6. Okay, BMC, of course, verified boot, measured boot, all those like boot chain security, up to the IMA and up to the also Linux kernel security stuff. Yeah, and there will be very interesting talks there. And one of this talk will be from Maciej, and Maciej is going to Tokyo. So I hope you will find some good ramen there. And Maciej will talk about the future of platform security measurement in Linux, focusing on ever-growing impact of host security ID from LVFS of the FWPD project. And of course, we would like to discuss with Linux community what we can do with some drawbacks, with some problems, but also like what kind of edge cases we have, and maybe consider a little bit and brainstorm with some people. I know that Daniel Smith from Trenchboot will be there, and a bunch of other people. So definitely there will be discussion about potential extensions to HSI and how to improve the security index, security ID, sorry. And yeah, so congratulations, Maciej, and I hope you will have good trip and fun in Tokyo. And regarding the ZDM events, we're kind of canceling the approach to do it every quarter. So next is a ZDM event will be in May, 5th May 2026, and then the next one will be in November. So we're doing like kind of every 6 months. So this cadence was changed because of too many events that we handle, and of course we would like to make sure that we really preparing we're focusing also on our roadmaps, and hopefully we can prepare even more kind of flashy and kind of interesting in terms of impact presentations. And yeah, thank you very much for that. And I guess that's it for today. Thank you.
Thank you. Bye.